Hey folks, my name is Parker Ziegler. I'm a PhD candidate in computer science at UC Berkeley and a software engineer at the Climate Newsroom GRIST. I'm also the creator and lead developer of Cartokit, which is a new direct manipulation programming tool that allows you to develop interactive maps without actually writing any of the code yourself. And today I'm going to show off Cartokit a bit and show you how you could use the tool to build the kinds of ambitious, exciting interactive graphics we see published in national newsrooms today. So here I am in the Cartokit user interface. This is running live at alpha.cartokit.dev. I'm going to start off by popping open our code editor here by pressing the E key. And over here on the right is the program that Cartokit has already generated for this map we see on screen. This is a JavaScript program using MapLibre GL.js. And we can see that it's a pretty simple program. But if I start interacting with the map here, and in this case I'm going to pan and zoom us to where I am here in the Bay Area, we can see that our program is updating in real time. These center and zoom values actually change in response to my interactions with the map. So this is what we mean by direct manipulation programming. I'm directly manipulating the program output, the map in this instance, and the system is actually handling writing that code for me. All right, so let's get started actually doing something interesting, building one of these graphics I promised we would build. And for this demo, I'm going to go ahead and use this graphic from Harry Stevens, formerly at the Washington Post, now at the New York Times. This was a piece Harry worked on a few years ago looking at change in deaths linked to temperature-related exposure under different emission scenarios. It's a really fascinating piece. I definitely encourage you to go read it, and I absolutely love this graphic. Harry was also kind enough to open source the data for this piece, so we can go ahead and load that data directly into Cartokit and start mapping. Okay, so back over here in Cartokit, I'm going to start by pressing my L key to open the Add Layer modal. And then I have that data from Harry hosted on my own R2 instance in object storage. And I'll go ahead and give the layer a display name of climate impact regions, something like that. You can see that data loads almost instantaneously in Cartokit. Cartokit is very fast with data loading. And I also have these nice tooltips that sort of show up immediately, so I'm able to actually inspect individual polygons and see the attribute values for different columns of the data set. And again, if we pop open our code editor, we'll see that our program has changed, right? We now have this call to add source that's actually adding in that GeoJSON data, and then add layer calls for the fill and stroke of this polygon layer. All right, so to start actually making Harry's map, the first thing I'm going to do is get us out of this kind of web Mercator world and into a globe projection. So I'll go ahead and press the G key in Cartokit, and that'll transition us to using a globe projection. And again, we can see that we have this new bit of code with this set projection call that's actually ended up here in Cartokit. Okay, and now let's start actually visualizing some data. So I can go ahead and click on any feature in this layer, and this will pop open this properties panel. And the particular layer type that Harry is using in the story is what's called a choropleth layer. We're going to be actually, using the fill color of the polygons to encode some particular data value. And Cartokit has really nice support for choropleths out of the box. So we can just click in that layer type drop down, and we'll transition immediately to a choropleth map. And we can see that Cartokit has chosen some defaults for us. It's visualizing this year's 2020 to 2039 attribute. It's using things like a quantile classifier to actually bin the data into discrete breaks. And then we have this kind of sequential orangish scheme going on here. So I'm going to start making some edits to this map to bring it a little bit closer to the one Harry developed for the story. We'll just thin out this stroke quite a bit and use sort of a nice light white to make these polygons pop just a little bit. I also am going to change the attribute here from this year's 2020, 2039 to the one he's using in the story, 2080 to 2099. And then finally, I'm also going to actually change the color scheme here. So in this instance, I want to use this sort of diverging purple-green color scheme. Now, if we go back to the story, we'll see that the scheme is actually kind of reversed. Negative areas are in a darker green, and more positive areas, again, an increase in deaths, are actually in purple here. So in Cartokit, I can match that by just using this nice reverse scheme button here to change the scheme direction. And so now we're getting actually pretty close to the map that Harry actually published in the story. And we can see here our code has been getting updated sort of in real time as we work. The last step I want to do is actually try to match the sort of breaks in the data that Harry's using. Again, we can see in the legend that we have these sort of nice round breaks at these sort of round numbers here. Now, this is the kind of thing you can do in Cartokit, but it is a little bit tedious to do directly in the UI. So for this, I'm actually going to defer this to a language model to do for me, in this case, GPT 5.1. And I'm going to prompt this with something like, bin the data into 9 steps using a manual classifier. Use the following thresholds. And then we'll specify breaks that are pretty similar to the ones that Harry has in the story. All right, and now we'll hand that off to GPT 5.1 to do for us. And the model's going to think a little bit, but look at that. Everything went nice. If we look over in our legend here, we can see that GPT 5.1 has actually applied the correct breaks that we asked for. We can actually go ahead and pop open this property menu. We can see that we're using our manual classifier now. And if you hit these 3 dots, we can see that our breaks have all been set. And again, we can also look here in the program. So we have all these nice ways of verifying that the language model did exactly what we asked for, nothing more, nothing less. All right, so I'm pretty happy with this map, honestly. Maybe I'll do something like bump up the opacity to 90% to make those a little bit darker. But overall, we have something that looks pretty darn similar to what Harry published in the piece. So now I've kind of finished off the work that I really want to do in Cartokit. The last thing I'd like to do is sort of match that animation for the story, but as of right now, Cartokit doesn't have support for animation. But that's totally fine, right? I have access to the JavaScript program. So I'm gonna go ahead over here and hit this copy program. And then I'm gonna go over to my text editor. So here I have a new blank Vite project set up. This is a totally empty Vite project. It has a empty TypeScript file, a sort of bare bones index.js file, a pretty bare bones CSS file. There's not a whole lot going on in here. And I can actually paste code directly in here. And the one thing I actually want to change is I'm going to go back into Cartokit. This is JavaScript right now, but I can actually tell Cartokit to generate TypeScript for me instead. So I'll just change that option for TypeScript instead, recopy that program, and then paste it directly in here. Okay, so I have that program that Cartokit generated for me, and now this is running in my own Vite project. And then I have this Vite project running at localhost 5174. So we'll go ahead and load that up. And again, we can see that that map I was just working on in Cartokit is reproduced exactly in my Vite project, right? So awesome. I have access to that code directly. Cartokit helped me get this sort of nice skeleton, and now I can begin customizing this. So I'll go back over here, and I have already written kind of this animate function that's going to animate us between these different sort of focus areas from the story, like the United States, India, Finland, Niger. And then I just have the simple animate through centroids function that's basically just going to handle actually rotating the globe to each of those centroids for each of those countries. So I'll go back into my index file. And in this case, I'll go ahead and just import that animate through centroids function. And then I'm just going to pop that really right at the end of my map.onload callback. So I know that my map is created at this point. and I'll go ahead and save that. And now we'll see, if I go back to my Veep project, that we have this nice sort of spinning, rotating, animating globe that, again, kind of matches Harry's piece pretty nicely. It's a little bit more zoomed in. I could tweak things like the zoom level and stuff like that. But overall, I'm pretty happy that we've arrived at something, pretty similar to what Harry actually built. And we used Cartokit to get most of the way there, which I think I'm really excited about. So that's all I have for you today. Thanks a lot for following along. Please go and try Cartokit at alpha.cartokit.dev and reach out to me on Blue Sky if you have any questions or want to get more involved. Thanks a bunch.